I'm Stephen Payton. I'm the environmental assistant for the Seldovia Village Tribe. I was born and raised here in Seldovia, and I've been doing the sampling for ocean acidification for the Alutiiq Pride Shellfish Hatchery for about 3 years now. When I was a kid, my parents worked on an oyster farm out at Jackaloff Bay. We lived off the ocean most of my life, and we were pretty lucky to be able to eat oysters and mussels and crab. It's hard to find clams these days, and you try and pass that on to your kids. I have 3 kids now, and we go out clamming, and it's a lot harder to do than it was when I was a kid. We're here sampling for ocean acidification because it's a pretty big worry for our community also. Our clam populations have already declined pretty heavily, and it's just another threat to one of our resources.
Alaska is important to the study of ocean acidification because its cold water are naturally higher in carbon dioxide than warmer waters further south. Factors such as glacial melt, deep fjords, and upwelling can lower the pH level throughout the year and increases the potential for coastal waters around Alaska to be even more vulnerable to ocean acidification. Ocean acidification is a change in ocean chemistry caused by seawater absorbing excess carbon dioxide from the atmosphere. Carbon dioxide mixes with the seawater to form carbonic acid. This reaction increases hydrogen ions, which leads to lower pH and greater acidity. It also decreases the availability of carbonic ions, which are an important building block for the many calcifying organisms, such as clams, oysters, or crabs. We use the term aragonite saturation to measure the carbonic acid concentration. When the aragonite saturation falls below 1.3, these organisms become stressed. And when the aragonite saturation level is less than 1, shells and skeletal structures begin to dissolve.
A number of years ago, the Alutiiq Pride Shellfish Hatchery was approached by scientists on the West Coast asking us if we were seeing any signs of ocean acidification in our shellfish hatchery. And we didn't have any idea whether we were or not. We had understood that pH and acidifying oceans would be a problem for our shellfish hatchery, but we didn't know how we could measure it.
The Chugach Regional Resources Commission instituted a water quality program to include their communities in the Prince William Sound and Lower Cook Inlet. The success of that program has expanded the sampling to other regions in Alaska, and we currently have 15 partners around the state. Our community samplers are the backbone of this program, and it's through their dedication to the sampling protocols that has made this program so successful. And through them, we can help enlighten local residents to the reality of ocean acidification and the potential impacts on their health and well-being.
Hi, I'm Naomi McMullen. I'm from Port Graham, Alaska. I am the environmental planner for the EPA IGAP program, and today we will be doing some water sampling for ocean acidification. What we got here is the YSI, which will help us get our readings for salinity, oxygen, and pH. So here's the instrument. We just go ahead and pop it in the water after we turn on our device. And we're going to auto-stable all of our dissolved oxygen, the conductivity, and a few other things. After the auto-stabilizer is on, we'll go ahead, wash out our bottle. We just put it in the water a few times, give it a few rinses. That way it'll clean out anything that's already in there. Go ahead and let it fill up a little. Pop out some of the water. We'll pull this out. That way we can get a on-point reading of the temperature. And after we get our readings from that, let's say 13.3, we're gonna take this mercuric chloride, the solution, which stabilizes the sample, so that way when they go and test it with the percolator, nothing will have changed. After I cap the bottle, I take it back to the office and I put it into the action packer tote that they send me. After about 12 to 15 samples, I will then package it up, send it to Seward so that way they can get it tested into the percolator.
The percolator allows us to take a sample of seawater and determine what the total CO2 content is of that seawater. This state-of-the-art machine breaks it down into two different parts, partial CO2 and total CO2. What that does is it takes pH and breaks it into categories that we can't monitor with just a pH meter, and so that we can find out exactly what's going on with the carbonate chemistry in that sample. What we do is we get a sample from the community and we wire it into the percolator and take that sample within a few minutes and determine what its content for carbonate minerals are.
We've been able to characterize and profile carbonate minerals over time in specific sites. For instance, when looking at the aragonite saturation levels throughout a year in Seldovia, we found that in the summer months, the aragonite saturation level reaches 2.5 or higher. This is due to increased sunlight and large blooms of phytoplankton absorbing the carbon dioxide. The opposite occurs in the winter months when photosynthesis is reduced and the aragonite saturation levels are much lower. This is valuable in linking what happens in the open ocean to the nearshore sampling that we do here at the Alutiiq Pride Shellfish Hatchery and at our communities around Southcentral Alaska.
The ocean acidification program that we've been working on with the Alutiiq Pride Shellfish Hatchery, it's been something that's pretty important to us because the clams, of course, are needing that to be able to build their shells. And if there's the ocean acidification happening where they can't build the shells, then they start dissolving shells. You know, we want to know that to try and get the, ahead of something that might be coming here.
Some of the goals of this study are to allow the tribes and the villages to be able to ascertain where good beaches are for restoration. If they know that a certain beach where they have been collecting important clam species over time is going to be impacted, it's quite possible that the hatchery could help produce more clams for that locale and perhaps plant them in a better location.
You know, this seemed like just a simple thing we were going to get to do to help out another organization, and it's turned into a really cool friendship. We like working a lot with the hatchery and Chugach Regional Resources Commission. It's been a lot of fun.
Our hope for the future of this project is to involve more communities, to train more samplers, to give us a deeper understanding of ocean acidification in Alaska.